I'm very pleased to introduce you to the modern methods of production technology management. First of all, I would like to introduce myself. My name is Alexander Schönmann, and I'm working with the Chair for Industrial Management and Assembly Technologies as a research associate since 2014. In the next 6 to 7 minutes, we are going to learn the core principles of an effective and efficient production technology management developed within the sub-projects B3 and T2 of our research center. While product technology management is already well established in the industrial practice, production, or also called manufacturing technology management, is still a fruitful field of research as we see in the following. The main idea and the goal of the sub-project T2 is to transfer the developed approaches into the industrial application. But first of all, why do we need production technology management? The identification, evaluation, and planning of production technologies is still a challenging task of producing companies. Applying the most suitable production technologies leads to reduced production costs and shows potential for increasing the product quality. Therefore, we will follow some of the key questions gathered within the past 10 years on industrial projects and research results. For example, how to identify production technologies, how to evaluate and select suitable technologies, or how to generate technology chains and how to evaluate technology chains. Of course, we cannot discuss each developed model in a great detail here, but we need to understand the 4 essential parts of a successful industrial production technology management. Therefore, we distinguish 4 main parts as highlighted in the figure, called identification of production technologies, the maturity evaluation, the economic evaluation considering uncertainties, for example, using a Monte Carlo simulation approach, and the planning of production technologies using roadmap approaches. In the following, we will discuss the most relevant characteristics of the two above mentioned areas. On the right-hand side, there's an overview of the 5 main topics we are going to discuss in more detail. First of all, I will present a method which supports to identify alternative production technologies. Then these technologies need to be evaluated in terms of their maturity and potential, applying our developed models. Summarizing the speech, I would like to discuss a real industrial application of the presented models and methods. For effectively identifying suitable production technologies, we need to discuss how to describe our technology need, how to search and where to search to find technologies, and how to evaluate the gathered information. The developed method performing a systematic search consists of 6 steps, beginning with the search field deduction and finding suitable sources, as well as how to evaluate the gathered information. After identifying concurrent production technologies, we need to store the gathered information. Supporting this task, a technology profile, also called a technology one-pager, was developed. Increasing the transparency of the selection process, the technology radar serves as a relevant model. It is displayed the maturity and also the potential. Evaluating the technical feasibility, the technology's maturity, and even the technology's potential will serve as a guideline for the pre-selection process of suitable production technologies with a further detailed. But how to evaluate the technology's maturity? Of course, the idea of evaluating a technology's maturity is not brand new. There are some qualitative models already available, for example, the technology lifecycle model as displayed in the figure. But the way and method how to handle this challenging task is worth to be presented in a minute. This model was developed by sub-project B3. Based on the work of Menkens and Brousseau, Schindler transferred the intuitive and only qualitative evaluation process into a transparent, standardized, and easy understandable questionnaire design, distinguishing 7 steps of maturity as displayed in the figure. From basic research to industrial use in serial production environment, the developed model enjoys great popularity in the industrial application. Since products are mostly produced applying not one but a series of production technologies, so-called technology chains, need to be generated and evaluated economically. Therefore, three types of interdependencies are taken into account: the interrelationship among product features, the interrelationship among technologies, and the interrelationship among features and technologies. Summarizing the speech, we address the continuous technological modernization activities using a real industrial application of the presented methods and models. One of our industrial partners was questioning himself if the established production technology of resistance spot welding is the most suitable one for satisfying the current and future requirements. The first step was to identify alternative technological solutions by applying the method of the identification of production technologies. Laser welding and lasing soldering were identified among others. For storing and visualizing the gathered information in a transparent way, the technology profile was applied. Evaluating the technical feasibility, the technology's maturity, and the technology's potential supports to pre-select the most suitable technologies considered in the following detailed economic evaluation. Therefore, technology chains were generated and economically evaluated considering uncertainties by applying the Monte Carlo simulation method. This information serves as a solid basis for decision-making if a technology change will increase the profitability of the company or even not. Thank you very much for listening, and for further questions, please do not hesitate to contact me. You will find the contact details on the website of our research project. Thank you very much.